In 1980, a scientific paper was published in the journal Nature describing a fossil discovery that shook the world. This discovery pushed back the origin of mammals on Earth by over 60 million years. But this wasn't a big, famous event like the discovery of Lucy, the Australopithecus afarensis skeleton. In fact, the story behind this incredible discovery is almost unknown outside of academic circles. So what makes this find so important? What did these fossils tell us about our origins? And why should you care? Hi, it's me, and welcome to Paleo Logic. Okay, let's start at the beginning. Mammals are a type of vertebrate. That means that we have backbones. Vertebrates can be divided into two groups, those that lay eggs and those that give birth to live young. Birds and reptiles are in the egg-laying group, which is called a monophyletic group or clade. We're in the other group, the one that gives birth to live young. This group was called Mammalia. Now, until the early 1980s, scientists thought that this group had only been around for about 200 million years. That's how old the oldest mammal fossils were. But that all changed with the discovery of Morganucodon, an early mammal from the Triassic period that lived in what is now Europe and North America. Morganucodon was amazing because it was much older than any other mammal that had ever been found. It was about the size of a mouse, but it looked more like a shrew. It had a long snout, large eyes and ears, and it had sharp teeth for catching insects. It's not exactly clear where Morganucodon fits into the mammalian family tree, but it's thought to be related to the ancestors of modern shrews. Importantly, Morganucodon was small, like shrew-sized. All other known mammal fossils from before this discovery had been small, shrew-sized creatures. Well, in 1980, another set of fossils was discovered. These fossils were also of early mammals, but they were huge. They were about the size of a hippopotamus, and they were named Ambulocetus. The species was called Ambulocetus isquigulastensis, and it was found in Argentina. There was a problem though. According to the prevailing theory at the time, mammals were supposed to have been shrew-sized throughout most of the Mesozoic era, the age of dinosaurs. These new fossils seemed to indicate otherwise. How could mammals have been huge when all the evidence pointed to them being tiny? Luckily for these fossils, they fell into the hands of two paleontologists named José Bonaparte and his wife, Maria. They had a radical idea. What if there was some sort of connection between these two groups of mammals? Maybe Morganucodon wasn't the ancestral mammal after all. Perhaps it was just a small example of a much larger group of mammals that had been around since the Triassic. To test this hypothesis, they needed to find more fossils. And so they went to the fossil-rich deserts of southwestern United States to look for them. They didn't have to search for long. Within a few months, they had found several hundred specimens of a new kind of mammal from the Triassic period. These specimens were mostly jaw fragments with teeth, but they also included a few skulls and partial skeletons. They named the new mammal Ghost Ranchianicodon, and once they looked closely at the anatomy of this creature, they realized that it was very similar to Ambulocetus, except that it was much smaller, about the size of a raccoon. This told them two things. First, Ambulocetus wasn't an early ancestor of modern whales. It was actually an early relative of modern shrews. Second, mammals had actually been medium-sized throughout the Mesozoic. They hadn't diversified until much later. So what caused this explosion of diversity? Why did mammals suddenly get so big? To answer this question, the paleontologists traveled to the American Museum of Natural History in New York City to examine some famous fossils. One of these was a dinosaur, Camptosaurus dispar, a herbivorous sauropod that lived in what is now North America during the late Jurassic. It was about 10 meters long and weighed over 3 tons. The other was a relative of Smilodon, the saber-toothed cat called Homotherium serum. This specimen was huge. It was about the size of a lion, and it lived in North America during the Pleistocene epoch, which lasted from about 2.6 million to 11,700 years ago. The scientists noticed something weird about their limb bones. Compared to the length of their bodies, the bones were unusually short. This indicated that these animals had relatively large shoulders and chests, which meant that they had strong forelimbs. This got the scientists thinking, could it be that these animals were adapted to climbing? After all, most animals that climb have short, sturdy limbs. They need to have large muscles to support themselves while they're off the ground. Then they looked at their teeth. Both of these animals were carnivores, but the saber-toothed cat had longer, more slender teeth than the dinosaur. This indicated that they had different diets. The dinosaur was probably a generalist that ate anything it could catch. The saber-toothed cat was probably an expert hunter that specialized in taking down large prey. When the scientists put all of this together, they had a pretty good idea of what these animals were like. The dinosaur was probably a kind of bear, large, bulky, and good at climbing trees. The saber-toothed cat was probably a kind of cougar, lithe, and good at chasing prey through underbrush. In other words, both of these animals were incredibly versatile predators, and they both lived during major environmental shifts. The dinosaur lived at the end of the Jurassic period, which was marked by a mass extinction event. The saber-toothed cat lived during the late Pleistocene, which was marked by the advent of the Ice Ages. The scientists realized that these two animals weren't special. In fact, there were hundreds of similar examples throughout the fossil record. Just before major environmental changes, there were usually a few species that were well suited to a wide range of habitats. These were the K-adapters, organisms that had features that allowed them to thrive in many environments. The scientists hypothesized that these K-strategists were the ones that survived mass extinctions and other major environmental changes. Because they were so adaptable, they quickly became abundant. Then over time, they gave rise to a bunch of new species that were adapted to live in particular environments. These are the strategists, organisms that specialize in a narrow range of habitats. Using this model, the scientists constructed a graph showing the relationship between species diversity and time. On the graph, the horizontal axis represented time and the vertical axis represented the number of species. As time went on, the number of species increased slowly at first, then suddenly jumped up dramatically. This pattern is called an exponential increase, and it happens whenever a new ecological vacancy opens up. For example, when a mass extinction kills off most of the species in an ecosystem, a few survivors will notice that there are fewer predators or less competition for resources, so they will reproduce rapidly and spread out into the open niches. Their descendants will eventually fill up the niches too, and the rate of speciation will slow down again. These exponential increases don't happen overnight. In fact, they can take millions of years. But when they do happen, they can have a huge impact on the history of life on Earth. For example, the end Permian mass extinction wiped out about 90% of all marine species and 70% of terrestrial vertebrates. This created a huge opportunity for mammals. Small mammals that had previously been living in the shadows of dinosaurs suddenly found themselves in a world without large predators. They quickly diversified and spread out into many new habitats. Later, the asteroid impact that killed off the dinosaurs caused another huge increase in mammalian diversity. Now, these events aren't the only times that mammals have diversified. In fact, there have been 6 major events in mammalian history. 5 of them have been caused by environmental shifts, and the 6th may be happening right now. Here's a quick breakdown of each event. First, there was the end Permian extinction, which happened about 252 million years ago. This allowed small proto-mammals to diversify. Then there was the end Triassic extinction, which happened about 201 million years ago. This allowed the ancestors of crocodilians and turtles to diversify. Next came the end Cretaceous extinction, which happened about 66 million years ago. You probably know what this one is. It's the asteroid impact that killed off the dinosaurs. This allowed mammals like Ambulocetus to diversify. Next is the first big radiation of placental mammals, which happened about 65 million years ago. This was probably caused by the development of the placenta, which allowed mammals to grow bigger and live in more diverse habitats. Finally, there's the Pleistocene epoch, which began about 2.6 million years ago and ended about 11,700 years ago. This epoch saw the rise and fall of many large mammals, including mammoths, mastodons, saber-toothed cats, and giant ground sloths. The end of the Pleistocene was marked by the Younger Dryas, a period of rapid climate change that allowed humans to spread out across the globe. Okay, so that was a lot of background information. But here's the point. We're in the middle of the sixth big radiation of mammals right now. Humans are causing rapid environmental change all over the planet. And wherever humans go, there's a mass extinction event following close behind. This means that there's going to be a huge opportunity for new life to evolve. And who knows? Maybe some of you will be around to see it. Speaking of new life, I just want to say thank you to my newest supporters. I really appreciate your support. If you want to support the channel too, check out the links below. As always, thank you all so much for watching. And remember, be excellent to each other.